Here's a fun and challenging problem we can try. Given the graph of f of x equals x cubed minus 4x plus 1, and its tangent line at the point negative 1 comma 4, find the area of the region bounded by those two graphs. So the picture shows us the shaded region that we're trying to find the area of. But let's not use any technology here to find this. Let's do this one old school with our brain power. So we're not given the equation of the tangent line. We have to come up with that ourselves. So that's a fun, well, maybe not fun, but maybe a routine process that you guys should all know, right? We need to take the derivative because the derivative gives us the slope. And we're interested at the point negative 1 comma 4. So when x equals negative 1, we get a slope of negative 1. So our tangent line, I'll call it t of x, has the equation t of x equals the y value plus the slope times x minus the x value. Or we can simplify that to be negative x plus 3. All right, so t of x equals negative x plus 3. That's the equation of this line right here. And f of x is the cubic function x cubed minus 4x plus 1. All right, so now we need to find those points of intersection, right? So we're going to take f of x and set that equal to t of x. Or x cubed minus 4x plus 1 is equal to negative x plus 3. We've got a cubic that we have to solve. So go back to your Algebra 2 days and refresh your memory as to how we can deal with a cubic. One thing we already know is that one of the solutions to this cubic, there are 3 of them, one of the solutions is negative 1. Right? When x equals negative 1, the graphs coincide. In fact, furthermore, we know that x equals negative 1 has a multiplicity of 2. If you remember, the multiplicity of 2 means that we bounce off of the line that we're touching and turn around instead of going through it. So that means that, that x equals negative 1 is a 0 twice to this cubic function. So we'll just use our synthetic division to divide this out. And we'll divide it out twice. So we bring down the 1, multiply by negative 1, add, multiply, add, multiply, add. We get a remainder of 0, which isn't surprising. We've got a quadratic we can factor at this point, but why stop here when we know that negative 1 is going to work a second time? Add, multiply, add, and we get a remainder of 0 yet again. So this is actually, we just found negative 1 to be a double root, so that means that x plus 1 is a double factor, and x minus 2 is the remaining factor. So x equals 2 is that mystery value that we're looking for. X equals 2 is the x-coordinate of that mystery point of intersection, the y value being negative 2 plus 3, or 1. You can verify that by evaluating this function at x equals 2. We get 8 minus 8 plus 1. All right, so using a bit of to review. Got interrupted mid-sentence, so I hope this is making some sense. I think we just found the points of intersection here, and now we're ready to integrate, right? We're going to set up the integral. So the integral is going to start at this x value of negative 1. And is going to end at this x value of 2. So from negative 1 to 2 of top minus bottom. The top, in this case, is the tangent line, t of x. The bottom is the curve, f of x. So t of x minus f of x. And I want to stress that the setup here is one of the biggest things here. In fact, it's the biggest thing. It's not uncommon, in fact, for test questions to say, set up but do not evaluate an integral expression representing the area bounded by blah, blah, blah. So the rest of this is fairly routine. I'll go through it because it's not too bad. But the setup is by far the bigger piece of this. So make sure that we're putting t of x on top, because that's the top, at least for this shaded region. So t of x is negative x plus 3. And f of x is x cubed minus 4x plus 1. So we'll subtract those two. We'll integrate from negative 1 to 2. And that should give us the answer. So we'll take negative 1/2 x squared plus 3x. Actually, maybe I should simplify before I integrate. That would be smart, wouldn't it? Let's save ourselves some headache and have one fewer term. So let's see, we've got negative x minus negative 4x is going to be 3x. We've got 3 minus 1 is 2. And we've got a negative x cubed. You should recognize that cubic. That's the same cubic we said equal to 0 earlier to solve for the zeros. So if we were to graph this, we would actually have a cubic whose x-intercepts were at negative 1 and 2. So that's worth thinking about. So anyway, that's going to be a little bit easier to deal with here. So we'll go ahead and integrate. The 3x turns into the 3/2 x to the second. The 2 turns into a 2x, and the minus x cubed turns into a 1/4 x to the 4th. We'll evaluate that antiderivative at 2 and at negative 1, subtract the 2, and we're done. So 3/2 times 2 squared plus 2 times 2 minus 1/4, 2 to the 4th. Don't know why I have 2 parentheses here. I don't think that's necessary. And then we'll do the same with x equals negative 1. We'll have 3/2 times negative 1 squared plus 2 times negative 1 minus 1/4 times negative 1 to the 4th. So evaluating this, one of the 2's cancels out, and we're left with 6 plus 4. 2 of the 2's cancel out, and we're left with a minus 4. Here, positive 1. Here's a negative 1. And here's a positive 1. Okay? So this is 6 minus, well, let's see, common denominator would be 6 over 4 minus 8 over 4 minus 1 over 4. 6 minus 8 is negative 2, minus 1 is negative 3, so minus negative 3/4. So 6 plus 3/4, or 24 plus 3 over 4, which is 27 over 4, would be the area of that shaded region bounded by the cubic curve and its tangent line at the point negative 1, 4.